Let's consider a more complicated expression than the simple trinomial we already know how to factor. This particular kind of trinomial expression can look like this, or this. Look at them closely and you'll see they have a lot in common with simple trinomials. First, they are still trinomials. Each expression has 3 terms. Second, they all have the form x squared and x and a number. And this is important. The first coefficient, the number that goes with the x squared, is not 1. If the number was 1, you'd have 1x squared, which is the same as plain x squared, and you wouldn't need this module at all, because as we saw in the module on simple factoring, there's an easy way to factor a trinomial like that. But now we want a harder one, beginning not with x squared, but with 3x squared, or 17x squared, or 12x squared. The question is, how do we reduce this expression to the product of 2 binomials? Trial and error would be one way, but we're going to learn a recipe to find the right answer. It has a lot of steps, but you don't waste time guessing a lot of wrong answers. Recall our FOIL pattern for multiplying 2 binomials. The middle 2 terms combine, and we end up with our familiar trinomial. We already put this idea to good use, working backwards to factor a trinomial with only x squared in the first term. When we multiply 2 binomials like these, the coefficient of the first term in the resulting trinomial is not 1. It's not obvious how to get from the coefficient of x squared back to the coefficients of x, 2 in the first binomial and 3 in the second. Here's a preview of the recipe we will use to do it. Don't worry too much about why at this point, just be sure you get the how. We can ignore the signs and don't even need to know that, in this case, the middle term is x. Let's pretend it's just a star. We will split the middle term, the star, into 2 pieces with the same total value as our middle term. Now we have 4 terms. Next, split them into 2 groups. Cleverly, this method is known as factoring by grouping. We factor the first group, then we factor the second group, and then the magic happens. The entire expression can be factored again, and the result is a binomial multiplied by a binomial, the original expression we were looking for. So, that's what the whole process looks like. Split the middle term, group into 2 expressions, factor each of the 2, and then the final magic step. That doesn't seem too hard as an outline, but it gets a little tricky deciding how to split that middle term. We will have to apply all our factoring skills to picking just the right coefficients for those 2 new middle terms. Here's the recipe to follow. We use the 3 coefficients in the original trinomial, the numbers without the x's. Where did the minus 1 come from? We gave the middle term a coefficient of -1 because x can be thought of as 1x. It's the same thing. Now, here's the trick we use to find just the right coefficients for our 2 middle terms. We multiply the first and the third coefficients together. Now, look at our answer and at the middle coefficient. We have -72 and we have -1. Our next step is to answer this question. What 2 numbers multiply together to get -72 and have a difference of 1? It's a difference because we must multiply a positive and a negative number to get -72. Or, same thing, what 2 factors of 72 have a difference of 1? We start by lining up all the unique factors in order. Then we pick out the pair we want, the factors that have a difference between them of 1. This step should be familiar. It's just like the factoring you did in the module on simple factoring, when the trinomials had just 1x squared in the first term. 8 times 9 is 72. 8 and 9 have a difference of 1. We've got it. Now we go back to that middle term. We take our 8 and 9 and adjust their signs to give us a -1. 8 minus 9. That's it. 8 minus 9 is the same as -1. And to make it exactly the same, we put the x back in, too. 8x minus 9x is minus x. And we've done our split. We've broken our middle term into two terms without changing its value. Let me pause here to point out a couple of things. When we multiplied our first and third coefficients, 12 and -6, we got -72, and we looked for two factors with a difference of 1. That is, a difference equal to the middle coefficient, in this case, -1. Sometimes multiplying the first and third coefficients will give you a positive product. 6 times 2 gives us a positive 12 in this example. When the product is a positive number, you look for two factors which add up to that middle coefficient. So, positive product, look for the right sum. Negative product, look for the right difference. Okay, now we had a product of -72. We found two factors, 8 and 9, with a difference of 1. We adjusted our signs to equal our middle coefficient, -1. That gave us 4 terms. What next? A simple but tricky step of putting them into two groups. Why simple? Because we're just grouping them into parentheses. Then why tricky? Because in this example, a minus sign will fall before the second set of parentheses, and that minus sign affects everything inside them. The 9x is fine, but be careful with the -6. It becomes +6. Now, we've split and we've grouped. Now we factor the two groups separately. We do the first group first. We're looking for the largest common factor for 12x squared and 8x. What goes evenly into both? 4x, because 4x times 3x is 12x squared, and 4x times 2 is 8x. So we move the common factor outside the brackets of the first of our two expressions, and then we factor the second expression. What goes evenly into both 9x and 6? The answer? 3, because 3 times 3x is 9, and 3 times 2 is 6. So, we replace the second expression with its factors, making sure we keep that negative sign which lies between the two expressions. And that's when the magic happens. We now have a factor on the left and a factor on the right that are identical, 3x plus 2. How did that happen? Coincidence? No. It happens that way every time when we follow our recipe for splitting the middle term. In fact, if it doesn't happen that way, it's time to start over because you made a mistake somewhere. And now we have our answer almost. We split, we grouped, we factored, and now we have to finish with one final factoring step. Remember from the previous step how we found the common factor 3 in the two terms of the expression? Then we took the 3 and wrote it once by itself and followed it with the other factors grouped together in parentheses. With that in mind, let's go back to our problem in the big finish step, and we see, hey, there's a 3x plus 2 on the left and on the right. So we do the same thing. We take the 3x plus 2 and write it once by itself, and follow it with the other factors grouped together in their own parentheses. And we've done it. The crowd goes wild. We split, we grouped, we factored, and we finished it off by factoring again. And we got the two binomials we were looking for. We know these are the correct binomials because we can check by multiplying them together, using our FOIL pattern, to produce our original trinomial. Why have we spent so much time learning to factor trinomials? We'll put these skills to use later when we want to manipulate fractions and solve quadratic equations. If you're looking for more information on this kind of factoring, you'll find it in your textbook and on the self-tests. But you shouldn't have any trouble if you follow our recipe. Split, group, factor, and finish by factoring again. And don't forget how to take into account that extra coefficient in the first term. Multiply the first coefficient times the third coefficient and factor the result. Among the unique pairs of factors, find two factors which go together to equal the middle coefficient. If the product of the first and the third coefficient is positive, look for the sum of the two factors. If it's negative, look for the difference. Doing lots of problems is the best way to really make these new skills stick. You can start with this one. Pause the program until you've found your answer. When you're ready, click play again. Did you follow these steps? The solution is 6x minus 1 times 2x plus 3. But you already know that. If you checked your answer using FOIL, you'll find more examples in your textbook. Be sure to do some of them right away.